Hello students, how are you all? I hope you all are doing well. I am Mr. Prithviraj, I am your 9th class physics teacher. So today we will be discussing our new chapter, that is refraction of light. Refraction of light in a plane mirror or a plane surface. So the term refraction is very important. In your previous classes we have learned reflection, but here we are going to discuss about refraction. There is a letter changed, reflection to refraction, total meaning changed. How big the meaning is, the difference of meaning is, we will get to know in this particular chapter. And before we read this chapter, I need to tell you some things like please take care of yourself. Corona is a big issue, as we all know. So on the note of that, let us start this chapter. Here in this chapter, you will be learning, you will get to know about lot of stuffs like what exactly is refraction, how it helps, okay, what is the applications of refraction, the idea of refraction. Everything you will be getting. This all stuff you will be getting. And in this chapter we will cover an activity. Activity number 1, that is pencil in a bowl of water. Pencil in a bowl of water, the first activity. Second one, we will see activity number 2, where we will get to know an idea of refraction of light. Here we will get an idea of refraction of light. We will get an idea also over here. Then we will see activity number 3, where we will know the real meaning of refraction, and here you will get to know the term refraction and the definition of it. Along with we will get to know what is refractive index, we will get to know what is refractive index, and we will know what is meant by relative refractive index. What is relative refractive index? This also you will get to know, and along with that we will discuss about an important lab activity. We will discuss about an important lab activity, that is lab activity number 1. And lot of stuffs are there like Snell's law, derivation of Snell's law. Then activity number 5 we will conduct for a term known as total internal reflection, and we will get to know the explanation for critical angle, and we will do some experiments related to total internal reflection. We will get to know the application of total internal reflection, and lab activity number 2 also we will conduct. In this way we will get to know very important new things in your this class, in your particular chapter, that is called refraction of light. And you must know these all things will be helpful in your 10th class board exam, not only in board exam, in your previous higher classes also. Okay, so let's start this chapter. Before we start this chapter, I need to ask you what all things we know. What all things we know? First thing is a source of light, right? A source of light, opaque object, as well as a screen, when placed in a straight line we will get a shadow. You see, there is an opaque object, myself, suppose I will take myself. Back side a wall is there, and front somebody comes with a light. If the light, me and screen all are in the straight line, the screen will get a shadow, an outline of my particular body, right? It is about formation of shadow, we know that very well. On the next step is, light always travels in a straight line. This also we know very well from our 7th, 6th classes. In our 8th class also we have conducted some experiments where it is very clear that light always travels in a straight line, right? Next is laws of reflection. We know what are laws of reflection. The angle of incidence is always equal to the angle of reflection, and the incident ray, the refracted ray, the point of incidence, the plane on which you are doing, they all lie on the same plane. This is what I have explained to you in your previous classes. These all things we know. And what we need to know in this particular topic we don't know anything about refraction, right? So what we will get? Coin. Whenever you place a coin inside a tub, okay, suppose there is a tub, you will place a coin. Now what will happen? The coin will be appear to rise, but when you will touch that particular position, the coin is not there, it is below. Okay, but if you put it down, you will see that is something came up, that coin something came up. That's what you will see. But here you will find that the actual depth of coin is little bit inside the tub. That thing why we will discuss. Lemon in the glass appears big. Whenever placing a lemon inside a glass, you might have seen it appears big. That also you will get to know why it is happening. Glass printed, okay. When printed letters are there, suppose in your notebook, you need to take a glass slab upon it. You will see the letter will come up and they will appear to be bigger. Why they are appearing to be bigger? These all things we will understand in this particular chapter. So let's do our first activity. What it is? Pencil in a bowl of water. Pencil in a bowl of, I wrote H2O, H2O means water, right? Our first activity is pencil in a bowl of water. What we will take? We will take a beaker. We will place water. Along with water, we will place pencil as well. Okay. So we have drawn like this. But in reality, what will happen? The pencil will look slightly bent. When you will observe that the real pencil is like this, but it is slightly bent. It is slightly bent in this particular direction. Right? Yes. Slightly it bent in this particular direction. But actual position of the pencil is this. But you can see the pencil is coming a little bit slanty. Why? You need to see from two directions. One, observe from top side. You can observe from top side also like this, and you can observe from sideways. When you are observing from top, nothing is happening. The pencil is looking like this only, slanty. But if you are observing from side, you will see this. When you will observe like this, from side view, you will be seeing like this. Why? Because light strikes water, it slows down, making it look bent. Suppose when we are looking slanting, suppose suppose this is a glass. Okay, in this glass, what you call pencil is there. When you are looking like this, the light travels and strikes at where? Strikes on the glass. When light rays strikes on the glass, what will happen? It will slow down. It will slow down. When light slows down, what will happen? It will change. It will appear to be bent. The image will appear to be bent. Okay. Now next thing is, but when you are looking like this, it passes through the air, it speeds up. You are looking like this, it passes through directly, it speeds up, and you will see that is straight. No bending is happening. Fine. Okay. Now activity number 2. What exactly is activity number 2? I said we will get an idea about reflection. In activity number 2, we will get an idea about reflection. Means a question will arise. Why this thing is happening? What exactly is that? This is our observation number 2 or activity number 2. Let us consider a big wall. Okay, let us consider a big wall is there. Brick wall is there, huge wall is there. Suppose this is 30 feet long. How much long? The wall is around 30 feet long. Now a person is standing over here. A person is standing at the end of the wall. Suppose you are standing at this end of the wall. Now at this end of the wall, you are standing. Okay, you are standing at this end of the wall. And now what you need to do? See, the position of the wall should be opposite to sunlight. Sun need to be in this direction and the sunlight need to be fall upon this wall. In this position you need to stand. You will ask your friend to stand here, or you can stand upon there, and you will ask your friend to stand upon there by using a particular glass or shiny metal object. A shiny metal object. You are standing over there. Suppose I am your friend, I am holding a particular glass here. When I am holding a glass over here, you will see the light rays are falling upon the metal. It's not glass actually, it is a shiny surface. It's a polished metal also. You will see a object of sun. The sun's object, means sun itself. The image of the sun is appearing on the wall. Okay, the image of the sun is appearing on the wall. Why is this happening? This is also due to refraction only. How, we will get to know. Means it is giving us a reflection kind of thing, right? A shiny surface itself is giving a kind of reflection. Why? This all thing we will discuss, and we will understand what exactly is refraction now. Means the basic thing. I asked you the first question. Means first we have started discussing that when we are putting a particular coin inside a tub, that coin appears to be higher. Why it is appearing to be higher? That's what we will discuss. Suppose this is a tub. Okay, in this tub we have placed a coin. Okay, we have placed a coin. Now this coin is falling down. Now I placed a coin. Okay, what you need to understand is that these walls are opaque. The wall of the tub is opaque, so you cannot see. What you need to do? I am standing here. I didn't change my position. Suppose it is here. The bowl is in front of me like this. I cannot see the coin. Now what I will do? I will just pour water. When I pour water, what will happen? The coin appears. Now I can see the coin. Suppose coin it was like this. Suppose now it appears here. Now it appears here. What exactly happened? Are you thinking the coin floats? No, coin will never float. We know that its density is way more higher than our water. But why the coin is appearing to be higher? When you will try to touch that, you will not get coin. Coin is little bit deeper, but it is appearing to be there. Why? Here Fermat's principle will be helping us. Whose principle will help us? Let me write here. Here a scientist named Fermat. Fermat principle is applied. I will ask sir, what is Fermat's principle? Let us understand what exactly is Fermat's principle. Later we will see, we will deal with this particular diagram. It states that a light ray always travels in a path which requires shortest possible time to cover the distance between two given points. What it is telling? It states that a light ray says that a light ray always travels in a path where it requires less time. It requires less time to cover the path between two given points. Note it down. You won't get it over here. Anywhere you will never get it. This easy principle. So please note it down. Fermat's principle says that a light ray will always travel in a path. A light ray will always travel in a path where it requires very less time. Where it requires very less time to cover the path between any two given point. Suppose I am standing here, an object is standing in front of me. Now you can see the object. So light ray is traveling, and after traveling light ray, that reflected light ray is striking back in my eye. Then only I can see the object, right? Yes, the reflection is striking on my eyes. Then only I can see the object, right? Here what is happening? Suppose the object is a little bit down. So you need to understand. Here it is a straight line. Straight line is the only path which is very least distance. Suppose the object is a little bit down, means the light cannot come. If it need to come, it need to pass like this. Suppose here a person is standing, here another person is there. Now the reflected rays would come to your eye like this. Then only you can see. According to Fermat principle, the light will always cover the shortest possible time to cover the distance between two paths. Which is the shortest possible time? That is displacement. Displacement is what? A straight line path must be there, right? So that same thing is applied over here in this glass. What exactly is happening in the glass? Take example of the particular tube we will take. Tub. Now what happened? Inside the tub there was coin. Okay, inside tub there was coin. But when we place water, what will happen? Now water is coming up here, no? Now this is water layer. Until then. Now this particular coin, actual depth is this, but now it is appeared to be here. Now it appeared to be here. From where you are suppose looking? From where you are looking? From here. You are observing from here. At first you cannot see this. Okay, at first you cannot see this because what? The actual position was like this, no? But now you can see this. Why? Because light wanted to cover the shortest possible path which is possible in it. Okay. We observe that the light ray undergoes a change in its direction at the interface of the surface. What interface we are looking here? Here it is air. Until here it is air, no? And here it is water. So this is what our interface. At exactly the interface, what will happen? The light is changing its direction, no? Of course the light is changing its direction because that is what water. When direction is changed, the speed of light is also changed. It may decrease or it may have increased. It doesn't matter, but it changed. Okay, because of that change in path, the image comes up. The image comes up. It chooses a new path in order to minimize the distance to be traveled between the coin and eye. Here I is constant. I is constant. Here this coin is constant. But the image of the coin is appeared here. Why? Because it changed. It minimized the distance. The distance how it was before. It is like this now. But now what it did? It is choose this path only. It shifted it. It cancelled this particular distance. This particular distance has been cancelled. Now you can see directly over there. Although its actual position is like this, but image is this only. It is giving us an apparent image. Why? It minimized. It minimized the distance which need to be travelled. Okay. It is possible. How it is possible? It is possible only when the speed of light changes. It is possible only when the speed of light changes at the interface. We all know that distance is equal to what? We all know distance is equal to velocity multiplied by time, right? Distance is equal to velocity multiplied by time. If velocity changes, then only distance will change because they both are directly proportional. If velocity will decrease, distance will decrease. So here, in order to minimize the distance, it must minimize its speed as well. It must minimize its speed as well. So speed of light differs in the medium in which it travels. If you are talking about vacuum, in vacuum speed of light is something. If you are talking about water, in water speed of light is something else. In glass, the speed of light is somewhat else. So speed of light is not constant in each and every kind of medium. So speed of light always depends upon the nature of the surface as well as the optical density of the particular surface. Okay. Thus it can be concluded that speed of light changes with propagation of light from one medium to another medium. Whenever light goes from one medium to another medium, the speed of light changes. You need to understand this as well. When light passes from one medium to another medium, the change in speed is called refraction of light. So now we come to our original definition. What exactly it is? When light is traveling from one medium to other medium, suppose this is our air medium, this is our water medium. When light is traveling from air medium to water medium, speed of light changes. This change in speed of light is called refraction or the bending of light. Here you see the light ray is bent. This bending of light phenomena is called as refraction. The experiment showed that refraction depends on the speed of light in the transmission of medium. The speed of light depends on optical density as well. If you are asking, sir, what is optical density? Optical density means by looking you need to tell how dense that object is. We know that kerosene is less dense than that of water, but the optical density of kerosene is more than that of water. How? What exactly it is? We will discuss in our upcoming classes. Until then, bye bye.